Assalamualaikum to my panel, Puan Imawani binti Jamaluddin and Puan Nohaslina binti Hashim. My name is Fatina Zura binti Yahya. My metric number is D01 D0111910074. I'm from section 2 DKS2. My student code is B38. Today, I would like to present my project diploma, which is Universal Power Adapter. Uh, Introduction for this project. This project based on AC to DC rectifier, which is converting high AC voltage to low DC power voltage. Rectifier can be applied in many devices such as laptop, computer, television, and electronic devices. The design of this project is portable to use. The component is as expensive and easy to get. My problem statement: buy an electronic devices that currently causes the charger is not be given. Previously, do not have power adapter that can be used as a power supply if want to use as a laboratory power supply. Main source is currently AC. Therefore, if you want to use DC power supply, need to buy an equipment as power adapter. Therefore, it is proposed to produce universal power adapter as DC power supply. Uh, for objective to my project, to examine the circuit using power voltage simulation to design an universal power adapter of 5 volts, 9 volts, and 12 volts voltage, fixed voltage. Scope for this project: to design a rectifier, fixed voltage 5 volts, 9 volts, and 12 volts. Input voltage 240 volts AC to 12 volt DC by using transformer step down 240 volts to 12 volts. Voltage regulator that I use: LM7805, LM7809, and LM7812 will produce 5 volts, 9 volts, and 12 volts. Capacitor that I use: 2200 microfarad, will store energy from voltage regulator. And then last one, diode that I use: 1N4001, will converting AC to DC voltage. For my project background, DC electricity is easier to restore, especially on a small scale. Efficiency is higher for full wave rectifier, so output DC will be high. And last one, long-lasting uses. Feature of the project: first, able to converting high voltage to lower voltage, able to use for small scale voltage devices, and the last one, able to bring everywhere. Okay, for the components in my project, I use AC power cord, heatsink, jumper wire, transformer step down 240 volts to 12 volt, capacitor 2200 microfarad, diode 1N4001, and voltage regulator that I use, which is LM7805, LM7809, and LM7812. For my methodology, uh, for the flowchart, I will start the literature study, and then I will design, simulate, and test the circuit using the breadboard. If the circuit that I simulate or I test in the breadboard is not works, I will start again literature study and design, simulate, and test the circuit using breadboard. If the circuit works, I will build the hardware, and then my project will be end. This is my circuit diagram from the project. This is a block diagram. Uh, the next slide, I will explain about my block diagram. Okay, AC power cord able to flow 240 volts AC to the transformer. Transformer step down will converting 240 volt to 12 volt. Diode 1N4001 will be rectifier to converting AC to DC voltage, will flow to the voltage regulator and capacitor. The voltage regulator LM7805, LM7809, and LM7812 1, 2 will produce 5 volts, 9 volts, and 10 volt DC voltage. Capacitor will store energy from the voltage regulator, and the output voltage can be used to any load which is appropriate. Okay, for my safety requirement, to avoid any accident when using electronic component, make sure you hand drive before doing hardware test. Before the hardware test, all the component connections should be able to check continuity first. Using simulation first before starting the hardware test to avoid any damage for the electronic component. Okay, this is for my project demonstration. Okay, this is the AC voltage will be flow to the transformer. Transformer from the primary side is 240 volts. Will converting to the secondary side 12 volt. When the 12 volt will be flow to the rectifier, and rectifier will uh, produce DC voltage, and DC voltage will flow to the voltage regulator LM7805, LM7809, and LM7812. The voltage regulator will produce 5 volts, 9 volts, and 12 volt DC voltage. Function for the capacitor is will store the energy from the voltage regulator. Okay, this is my uh, project uh, simulation. The light for 5 voltage is dim. For the 9 voltage is low brightness, and the 12 volt will be brightness. Okay, we go to the project web simulation. Voltage regulator for LM7805 will produce 5 volts. LM7809 will produce 9 volts, and LM7812 will produce 10. Thank you. Okay, this is my model for the project. This is my result for the simulation. For 5 volts, the light is dim. For 9 volts, the light is less bright, and the 12 volts, the light is brightness. This my hardware result for 12 volts, 9 volts, and 5 volts. And this is my model for universal power adapter. For conclusion, the objective for this project has been achieved when the output voltage produced 5 volts, 9 volts, and 12 volts is able to create a rectifier that can be converting AC to DC from high voltage to lower voltage showed that transformer step down do a good performance to converting this high voltage. Project software give an advantage simulate the operation circuit simulation first before starting the hardware. So for my recommendation, it should be able to add a digital display. This can be more portable power adapter. Thank you.